You know, we have a situation where about 1 in 2 people dies of heart disease, and hardly anyone really talks about that much. You know, but you often hear people talking about B12 deficiency as though it's a real major problem. And yet, when you do your research, you see that it's not really a problem at all. And according to Dr. John McDougall, he says that out of 1 million people that you're ever going to see that are sick, he said you'd be lucky to find 1 out of that 1 million that you could genuinely say had a B12 deficiency that may have in any way contributed to that person's illness. So if that's the case, then why all this hysteria about B12? Well, first of all, we need to understand a number of things. First of all, B12 is not produced by animals. It's not produced by humans. It is produced by bacteria. The reason why B12 is present in animal products is because there are bacteria in the guts of the animals that were producing it. But that same bacteria is also present in a lot of other areas. For example, there's 20 known bacteria that produce B12. Some of them grow, for example, on the barks of trees. Some of them grow on the grass. Some of them grow in the soil, in running streams. Yeah, all these different areas. So there is a phenomenon that has intrigued and puzzled scientists for some time, and that is called the transmutation of metals. Now, this concept is that you could take one element, say for example sodium, and then that converts into another element, say like potassium or calcium. Now, we know that with radioactive elements that has been scientifically accepted that happens all the time. For example, you could have radium with, for example, 88 protons, for example, and then it goes through alpha decay and it loses 2 protons, and you end up with rhodon with 86 protons. Now, that's accepted that happens, but we're told it doesn't happen with elements outside of the radioactive elements. However, we know that from scientific experiments that does happen. For example, they've done experiments at certain universities in the United States where they've taken water, which is completely distilled and it's got no other elements in it other than the water. They put it out into sunlight, but enclosed in a vacuum sealed container, and they find that iron and calcium appear out of nowhere in there. So that there is some transformation that's going on that they cannot explain. One of the questions a lot of people often ask is about our history of mankind, and they put forward that as human beings that originally caveman used to kill animals, used to hunt animals and eat them, and so for that reason that is a natural diet for us. However, when you look at the scientific evidence, you can actually see that when they find remains of human beings that go back a long time, that mostly they tend to find plant-based foods that were in the stomach and in the intestines. They've also found that apart from like drawings in caves, where they've got animals, being thrown spears at and so forth, there's no real evidence that man did really eat meat in any great quantity. And in fact, when you have a look at the oldest fossil records that you have of human beings, and you have a look at the current human being, you can see that they're virtually identical. There's virtually zero difference between what we were then and what we are now. What we know now is that we are built as a herbivorous being, and the oldest fossil records also show that we were very similar. Even the examples of the missing links and so forth, they're now starting to say, well, Cro-Magnon man looks very similar to a lot of the fossils of the Cro-Magnon man, look almost exactly the same as certain tribes in Indonesia. They're saying that Neanderthal man looks very similar to a lot of tribes, 7-foot Africans, for example. And we're not seeing the huge differences, and certainly we're not seeing any evidence that we were any more equipped or any less equipped to eat animals back then as we are now. And so all of this stuff about this paleo diet that we're somehow, that's how man originated, that we were killing animals, there doesn't seem to be any evidence for it. There's just nothing but speculation about it. Well, one thing is for certain is that when you look at the populations that live the longest, they're the ones on a plant-based diet. From a water use point of view, it takes 50,000 litres of water to produce a kilo of beef, and only 500 to produce, say, a kilo of broccoli by comparison. So it uses a huge amount of resources. You know that it takes, a 5 hectare bit of land, you could feed 2 people with beef, and you could feed something like about 50 people with beans, for example. So as far as using our resources, there's no doubt that being on a plant-based diet would make a lot more sense. For example, we have a situation where there's 6.8 billion people on the planet, and yet the amount of grain that we feed cattle alone is enough to feed 8.7 billion people, more than the whole population of the world. And there's only 790 million people that are starving. We've now got the first situation ever. There's more obese people on the planet than there are starving people. Okay, so this is the society that we're in at the moment. Our thoughts have an absolutely incredible effect on our whole environment. Now, I'll give you some scientific examples of this. There was a Russian scientist by the name of Popinin, and he did an experiment where he took some human DNA and he put it in a tube in a vacuum. And there was no particles in there was just light photons. When he removed the human DNA, the photons had then arranged themselves into exactly the shape of the DNA. So in other words, he was able to affect a change in the environment just by putting some DNA in there. Now, there was another experiment done by the US military, and in this case what they did is they took a person and they took some shavings from the roof of their mouth, some DNA, and then they took that DNA, they started about 50 metres away from where the person was. Then they showed the person some films to evoke different emotions of happiness all the way to sadness and so forth. And what they found was that there was these oscillations as the person was becoming happier. The oscillations were faster and had a greater amplitude, and when a person was sad, the amplitude would be lower and it would be a lot slower. But what they found was that the DNA that was in a jar 50 metres away was exactly showing the same pattern at exactly the same time, with no time delay at all. I don't agree with either taking something like apple cider vinegar, or even worse, when people take hydrochloric acid because they think it's going to increase the hydrochloric acid in their stomach. What ends up happening is that as it's going through the saliva is trying to neutralise it, you see, we're all told that digestion is an acidic process, that we're using acids to break down the food. That's not what happens. I know this is controversial because that's not what we're taught, but if you look at the science and you look at the studies that have been done, you'll see that digestion is an alkalization process. Our saliva is mostly sodium bicarbonate. Yes, there are enzymes that are acidic like amylase and what have you, but they're only a small component of it. It's mostly sodium bicarbonate. So as you chew the food, you're breaking down the cellular membranes of the food, and you're releasing acids. The acids are inherent in the food. The enzymes are in the food already. Most people that know about raw foods know about enzymes, right? Well, they're effectively acids that break down the food. That is occurring when you chew the food. But those acids need to be neutralised, and that's what the sodium bicarbonate does. Then as it goes into the stomach, you have two things happening there. You have a production of sodium bicarbonate and you have a production of hydrochloric acid. The hydrochloric acid drops to the base of the stomach, to the pit of the stomach, away from where the food is. The food is basically on the top of the stomach, and that is where the sodium bicarbonate is. People that have a lot of heme iron from meat, for example, heme is a very strong oxidant and it damages healthy tissues. And if you have heme iron from meat, the body can't get rid of heme iron. It has no mechanism for it because it produces heme iron from non-heme iron that it gets from green leafy vegetables mainly and other vegetable sources. When it has too much heme iron, again it says, what am I going to do with this? I can't handle it. And then it'll park it in the liver. You'll get cirrhosis of the liver, you'll get hematosis, and then because it's such a strong oxidant, it will then destroy healthy tissue wherever it gets parked in other muscle tissues and so forth. Again, because the body wasn't designed to eat it in the first place. It's exactly the same with vitamin A. A lot of non-vegetarians will say to me, oh yeah, you can't rely on vitamin A from plant-based sources because you only get beta-carotene. The body then has to go to the extremely difficult task of converting it to vitamin A. Well, converting vitamin A from beta-carotene is one of the easiest things the body does. It just does it spontaneously. But if you get too much vitamin A from meat, then you've got big problems because, again, the body doesn't have a mechanism to get rid of it, and then it causes cellular deterioration in the body, and people get diseases from excess vitamin A.